Okay, so now we're going to learn how to evaluate trigonometric functions of non-acute angles.
What did you call me?
Yes. So let's take a look at the story so far. So we know how to evaluate trig functions at quadrantal angles. Remember, quadrantal angles are like 0, 90, 180, 270, and all the angles coterminal to those. Okay. And the way we evaluate trig function values at coterminal angles was merely selecting a point, for instance this point right here, and assigning, say, x equals 0, y equal 1, and evaluating r, which turns out to be 1. And so now you can see, for instance, that sine of 90 degrees, which you know to be y over r, is 1 over 1, which is 1. And this works for quadrantal angles because it's really easy to pick a point that's on an axis, right? It's just 0, comma, a number, or a number, comma, 0. And then we extended our theory to be able to take trig function values of 30 degrees, 45 degrees, and 60 degrees, because those angles land on these special triangles. And we determined that the side lengths of these triangles kept the following proportions, which means we could look at sine of, say, 60 degrees, which is opposite over hypotenuse, and we could determine that sine of 60 degrees is rad 3 over 2. Or tangent of 45 degrees, which is opposite over adjacent, would be 1 over 1, which is 1, etc. So if you're keeping track, we can evaluate trig function values at any quadrantal angle and at 30 degrees, 45 degrees, and 60 degrees. So what we're doing today is we're going to expand the range of angles whose trig functions we can evaluate to be any angle from any quadrant whose reference angle is 30, 45, or 60 degrees. So, okay, well, what's a reference angle? Well, it's basically like the quadrant 1 version of a given angle. So let's define it. Every non-quadrantal angle, say theta, has a reference angle, and we'll denote it with like a theta apostrophe. In math, that's often called a prime symbol. And what is a reference angle? Well, it's a positive acute angle read to or from the nearest side of the x-axis. Okay, so, well, what does this mean? Well, it means something slightly different depending on what quadrant you're working in. So let's take a look at quadrant 1. So suppose we have an angle theta here. Then its reference angle would be between the terminal side and the nearest side of the x-axis. So actually that would be exactly the same thing as angle theta. So in quadrant 1, an angle is its own reference angle. Okay, well, let's look at quadrant 2. So here's our quadrant 2 angle theta. And what is its reference angle? Well, its reference angle will be between the terminal side of theta and the nearest side of the x-axis. That would be, in this case, the left side. So there's our reference angle. And how would we calculate it? Well, we'd say that the reference angle we can see is 180 degrees minus theta. Okay, let's look at quadrant 3. So here's our angle theta. And its reference angle, theta prime, again, is between the nearest side of the x-axis and the terminal side of our angle. So that would be this guy right here. And here we can see that the reference angle, theta prime, is the original angle minus 180 degrees. And finally, in the fourth quadrant, so let's suppose there's our theta. And now the nearest side of the x-axis is back to being the positive side. So it'd be this little angle right in here. That's our theta prime. And we can see that theta prime is all the way around, so 360 degrees minus theta. So the way that we calculate a reference angle depends on the quadrant of the angle. But you can see that the reference angle is always acute, meaning it's always going to be between 0 and 90 degrees. It's always positive, and it always involves the x-axis, never the y-axis. In fact, in each of these drawings, we could have completely ignored the y-axis, and that may have in fact made life even easier. The y-axis is pure distraction when it comes to finding reference angles. They always involve the x-axis.
Yes, right there. There's the x-axis.
All right, well, we've got a couple of angles here that we need to find the reference angle for. So let's start with the 294. Well, 294 degrees, we can see that that's in quadrant 4. So let's just sketch roughly where it might be. We don't have to be very precise, but let's just say it's somewhere there. Where would its reference angle lie? Well, that would be this tiny little acute angle in here. Again, it's always between the nearest portion of the x-axis and the terminal side of the angle that you're dealing with. So we could see that our theta prime will be 360 degrees, which is a full revolution, minus the 294 degrees, which is 66 degrees. All right, let's look at part B, which is 883 degrees. And the first thing we should do is find an angle coterminal to 883 degrees, which is in the interval 0 to 360. So of course we'll just subtract 360 a bunch of times, but we know from experience at this point that we can subtract a bigger chunk like 720, which is 2 360s, and we will get 163. So now we just need the reference angle for 163 degrees. Okay, well, 163 degrees is in quadrant 2, which also means that 883, the original angle, is in quadrant 2. So let's quickly sketch it. Maybe it's something like that. So there's the 163, and the 883, which went around a couple times to get to 720 and then stopped there, was the original angle. But what we're really after is this little guy right in there, the reference angle. Again, always reads between the nearest portion of the x-axis and the angle that we're dealing with. So in this case, we can see that would be 180 degrees minus 163 degrees, which is 17 degrees. Okay, so like mentioned earlier, reference angles are always positive and they're always between 0 and 90 degrees because they're acute. Now before we go on, let me just show you the value of a reference angle. They preserve the magnitude of trig function values. So for instance, we know that 883 degrees has a reference angle of 17 degrees. So let's go to a calculator. So let's look at cosine of 883 degrees. And we can see it's negative 0.95, blah, blah, blah stuff. Okay, it's negative, of course, because that's a second quadrant angle, and cosine is negative in the second quadrant. And we found it was coterminal to 163, so that should give us exactly the same cosine value, and indeed it does. But now we got its reference angle of 17 degrees. What do we get there but positive 0.9563 blah blah blah. Okay, so the reference angle preserves the magnitude, although you lose the information about whether the original angle has a positive or negative sine value. And that's of course because all reference angles are acute, meaning they all eventually land in the first quadrant. Okay, this time we're given a reference angle and we're told to find an angle in a specific quadrant, quadrant 2. So let's draw what might be our answer, which is some quadrant 2 angle here. And theta will be our answer. We don't know what theta is yet, but we are given that its reference angle is 12 degrees. So just looking at the geometry of the situation, we can see that theta is the supplement of 12 degrees, right? So theta will be 180 degrees minus 12 degrees, and that would be 168 degrees. Okay, so what's so great about reference angles? Well, recall a little earlier, we saw that reference angles basically preserve trigonometric function values, except for the plus or the minus part. And let's see what trigonometric function values we already know how to figure out. So looking at a map of the quadrants here, we already know how to find trig function values of quadrantal angles. So that's 0 degrees, 90 degrees, 180 degrees, and 270 degrees. And using a 45-45-90 triangle, we know how to find the trig function values of 45 degrees. But because we know that, that means we can also find the trig function values for every angle whose reference angle is 45 degrees. So that would be these three other ones in here. So in the second quadrant, that's an angle of 135 degrees, whose reference angle is 45. In the third quadrant, that's 225 degrees. And in the fourth quadrant, that's 315 degrees. Okay. Using a 30-60-90 triangle, we can determine all the trig function values of 30 degrees. But that means that we know the trig function values for any angle whose reference angle is 30 degrees. So that would be this guy over here, which is 180 minus 30, so that's 150. And this guy right here, which is 180 plus 30, so that's 210. And this guy right here, which is 360 minus 30, so that's 330. Again, using a 30-60-90 triangle, we can find all the trig function values of 60 degrees. And of course, that means that we know all the 6 trig function values of any angle whose reference angle is 60 degrees. So that's like 180 minus 60, which is 120. Over here, that's 180 plus 60, which is 240. And over here, that's 360 minus 60, which is 300. So now look at all these angles that we are able to figure out the trig function values for, because their reference angle is 30, 45, or 60. And those angles lie on a 30-60-90 triangle or a 45-45-90 triangle. All right, so now we're going to evaluate sine of 225 degrees, cosine of 225 degrees, etc., all 6. So to do that, the first thing we need to do is find the reference angle for 225 degrees. And to do that, we're going to need its quadrant. So 225 degrees is in quadrant 3, right? It's between 180 and 270. So that tells us two things. One, it tells us how to find its reference angle, because we know that we just need to subtract 180 from it. And two, it tells us exactly which trigonometric functions will be positive and which ones will be negative. So let's start with the reference angle. So 225 degrees is in the third quadrant. So its reference angle will be this little gap right there between the nearest portion of the x-axis and the terminal side. So the reference angle would be 225 degrees minus 180 degrees, which is 45 degrees. Very good. 45 degrees is one of our special angles. So also, since 225 degrees is in quadrant 3, and we know all students take calculus, the t for quadrant 3 tells us that tangent and its reciprocal cotangent will be the only positive values. The other four trigonometric functions will produce negative values. Okay, so let's get ready to write down our answer here. And we know that everything's negative except for tangent and cotangent, so just put those negatives in now. So how do we get these actual values? Well, that's where the reference angle comes in handy. The values are going to be the same magnitude as what would be read off of the 45, 45, 90 triangle. And we know that the sides of the 45, 45, 90 triangle are 1, 1, and root 2. So now we can read off, say, sine of 45 degrees, which is opposite over hypotenuse, so that's 1 over root 2, which means that sine of 225 degrees will be negative 1 over root 2. Except, of course, we want to rationalize that, so we'll write it as root 2 over 2. And we'll just go and do this for the remaining 5. Cosine of 225 degrees in magnitude would be cosine of 45, which is adjacent over hypotenuse, so 1 over root 2. Again, that rationalizes to root 2 over 2. And those are both negative, you can see. Tangent of 225 degrees will be in magnitude the same as tangent of 45, which is opposite over adjacent, so 1 over 1 is 1. And it'll be positive because 225 degrees is in the third quadrant, where tangent is positive. Okay, so cosecant, well, that's the reciprocal of sine, so that's hypotenuse over opposite, and that's rad 2 over 1. So rad 2, except negative rad 2 for the 225 degrees, because quadrant 3. Secant of 225 degrees, hypotenuse over adjacent, so that's negative rad 2, and cotangent of 225, adjacent over opposite. And there we are. We're done. Okay, let's find sine of negative 240 degrees. So first thing we need to do is figure out what quadrant that's in and what its reference angle is. And we can figure out both of those by first finding the angle within 0 to 360 that's coterminal to this guy. And so we can simply add 360, we know that'll work. And what do we get? 120 degrees. So it's like we're really asking, what is the sine of 120 degrees? And what do we get out of that? Well, we know that this is in quadrant 2, and we can find its reference angle easily. So 120 degrees is about there. And its reference angle would be this little gap here to the nearest portion of the x-axis. So that would be 60 degrees. 180 minus 120, which is 60 degrees. Which means that the actual value of this trig function will be read off of the 30, 60, 90 triangle. And we should also check to see if our answer will be positive or negative. So in the second quadrant, sine is positive, which means that our answer will indeed be positive. Okay, so let's pull off the information we need from the 30, 60, 90 triangle. From the triangle, we can see that sine of 60 degrees is rad 3 over 2. And therefore, so is sine of 120. But what we're really after is sine of negative 240, but that's exactly the same as sine of 120, which is rad 3 over 2. And these two are positive because these angles are in the second quadrant, and sine is positive in the second quadrant. All students take calculus. Okay, let's find the cotangent of 690 degrees. And like before, we should find what angle between 0 and 360 this is coterminal to. And we'll just do that by subtracting 360 degrees. And it looks like our angle is 330. Well, that's in the fourth quadrant, which means 690 is in the fourth quadrant as well, because they're coterminal. They point in exactly the same direction. And knowing that 330 is in the fourth quadrant will help us find its reference angle. So there's our 330. And the 690 degrees goes around a whole time before stopping there. What we're after here is the reference angle, which is that little guy right in there. Again, it always involves the x-axis, whether it's positive or negative. Of course, here the positive side. So that would be a 30-degree angle because it would be 360 degrees minus 330 degrees, which gives us a reference angle of 30 degrees. Okay, that tells us we're going to need a 30, 60, 90 triangle, and we'll read the information off of 30 degrees there. Okay, well, we can pull off this triangle the cotangent of 30 degrees. And we know that cotangent is adjacent over opposite. So cotangent of 30 degrees is rad 3 over 1, or rad 3. But what we're really after is cotangent of 690 degrees, except 690 degrees is in the fourth quadrant. And in the fourth quadrant, all students take calculus, C for calculus. That means that cosine and its reciprocal secant are positive in the fourth quadrant. All the rest are negative, including cotangent. So this is going to be negative rad 3. Okay. As cotangent of 330 would also be negative rad 3, our intermediate coterminal angle. It's tempting when you're working these out to use a calculator to get these answers instantly, or to look them up on a table, or to look them up on a unit circle, which, if you don't know what that means, we're going to learn that very soon, so don't worry. I very much recommend that you do not deny yourself this process here. If you understand these two special triangles, this one and the 1, 1, root 2 with the 45, 45, 90 triangle, and you understand how to take any angle and drop it down to find its reference angle, and then use the triangles to produce a trig function value, then you are in really good shape. And you need to be able to produce these trig function values. Okay, so here we have a more complex trigonometric expression, and we can evaluate each of these pieces and add them together. So let's start with sine of 45 degrees. Well, we can read that one directly off of the 1, 1, root 2 triangle. Sine is opposite over hypotenuse, so that's 1 over rad 2, which would be rad 2 over 2. Okay, we also need cosine of 135 degrees. And for that, we're going to need the reference angle for 135. So 135 is right here in the second quadrant, and its reference angle is 45. That's 180 minus 135. Very good. So we know that in the second quadrant, cosine is negative. Only sine and cosecant are positive in the second quadrant. So all we need to do for the actual number is find the cosine of the reference angle, cosine of 45 degrees, which is adjacent over hypotenuse. So that's 1 over root 2, which is root 2 over 2. All right, so we have both the ingredients we need. We can actually go to the main expression here. So here's the expression, sine squared of 45 plus 3 cosine squared of 135 degrees. And remember, the squaring of the function means that you evaluate the function and then square after. So this is really the square of sine of 45 degrees. Well, that's root 2 over 2. And cosine of 135 degrees is negative root 2 over 2, and that's being squared. So, okay, squaring the numerator gives us 2. Squaring the denominator gives us 4, plus 3 times. Now, this is a negative quantity being squared, which will become positive. And again, we're going to get 2 over 4 when we square that thing. So this is like 1/2 plus 3/2 when you reduce those fractions, which is 4/2 or 2. So final answer, that whole thing just evaluates to 2. Okay, so here we're kind of working backwards a little bit. We're looking for a list of angles that satisfy this condition. So they have to be between 0 and 360. Thank goodness, those are all my favorite angles in there. And the sine of those angles must equal negative rad 3 over 2. All right, so let's first note that negative there. That's going to put a heavy restriction on what quadrants we're working with. So here sine is negative, which means we must be working with quadrants 3 and 4 because quadrant 1 and quadrant 2 have positive sine values. Okay, so as it turns out in this type of situation, each quadrant that's eligible, like quadrant 3 or quadrant 4, will produce a single angle value that works. And we are looking for an angle whose reference angle has a sine value of rad 3 over 2. So let's take a look at that rad 3 over 2 and ask ourselves which of the two triangles we know and love involve those particular numbers, like rad 3 and 2. And of course, that would be this guy, the 30, 60, 90 triangle. So take a look at that triangle and ask yourself which angle has a sine value of rad 3 over 2. And that angle would have to be 60 degrees, which means that we seek angles in quadrant 3 and 4 whose reference angle is 60 degrees. Okay, well, what would that be in quadrant 3? In quadrant 3, there's the angle with a reference angle of 60 degrees. But you can see we would just have to add 180 to that. So we would get theta equaling 60 plus 180, that's 240 degrees. Okay, what about quad 4? So in the fourth quadrant, there's our reference angle of 60 degrees. And the angle we're after is this guy right there. So, we know that that angle plus 60 is 360, which means that theta must be 360 minus 60, which is 300. So our conclusion would be that the angles are 240 degrees and 300 degrees.